Let's go over the last portion of lecture 9, which discusses the nutrients that are involved in blood health. But before that, let's just talk about blood a little bit. You probably know most of this, but maybe some stuff here you're not aware of. So the blood, other than carrying nutrients and oxygen to the cells, it has many other functions. One of them is to transport the immune cells, which are important for taking care of your body when you are undergoing an infection, for example, or by virus, bacteria, and whatnot, or to induce inflammation, which is sometimes useful for the body, and sometimes it is not so good. It also plays an important role in removing waste products that are generated from metabolism. So metabolism does not only produce good stuff or break down good stuff, it also generates waste, and this waste is carried to your kidney and whatnot through to your liver, to your kidneys, and the colon or digestive system through the blood. Okay, and it's made up of many things. You have erythrocytes, which is the red blood cells that have one main role, which is to transport the oxygen through the body. You have the leukocytes, aka the white cell blood cells, and these are important for the immune system. You have platelets, which are the cell fragments that assist in blood clotting. So these platelets are basically broken down cells that kind of bind together and are able to allow for blood clotting to happen. And then you have plasma. As we discussed in the fluid balance lecture, plasma is just the fluid portion of the blood without the cells. And so it contains minerals, nutrients, proteins, lipids, cholesterol, hormones, clotting factors, and whatnot. Okay. And so the blood is divided in somewhat specific ratios for a healthy person. If you take the blood, the whole blood that is taken from, let's say, a patient, and you run it in a centrifuge and rotate it using centrifugal force, you're able to separate it into its different components because they have different weights, let's say. And so plasma is about 55% of your blood. Red blood cells, so this is just the cells, is about 45% of your blood, and then the 1% remaining, or a bit less than 1%, is the platelets and the white blood cells. Now, obviously, this is only true for a healthy person. If you are, for example, sick, the amount of white blood cells will probably increase in your body, and so that means it will increase in your blood. Also, if you have poor fluid balance, this will decrease or increase depending on which side you're on. And so this is not set in stone, but in general, this is the distribution. Okay, and so again, to go over the nutrients, because we're interested in nutrition to maintain health. So in this case, we're talking about nutrients that are important for blood health, and obviously there are a few of them. And like we did in the previous lectures, I'll just cover a few of them just to give you an idea of how we think of the nutrients in terms of blood health. Okay. So iron, zinc, copper, vitamin K, folate, and vitamin B12 are all important for blood health. And if you're interested in the RDAs, you can take a look at this side here. Okay. For example, iron, usually women require more iron than men due to their menstrual cycle. If they are in the menopause state or stage of life, I would say, if they're pregnant or lactating, right, they require a little bit more iron than men, as you can see here. Okay. There are two forms that are found in food, the heme iron and non-heme iron, and this is just what is bound. It's basically what's bound to the iron. And so when you eat food, you can either acquire a heme iron, which, as the name implies, is probably bound to a heme group. Non-heme iron is an iron that is bound to anything else. Okay, and heme iron is usually found in animal-based foods and is known to be more absorbable because the body is able to kind of extract the iron from it easily. Non-heme iron, on the other hand, is found in plant-based products and not easily absorbed. And this is just because there isn't only one shape or form. There are many types of non-heme iron. Some of them are more hidden within the molecule than others, and so it is harder to kind of digest. Okay, it exists in two forms. You have the ferrous and the ferric forms. The ferrous is Fe2 plus, so it's the reduced form, and the oxidized form is Fe3 plus, which is the ferric form. Okay, so there are a few things that impair iron absorption because iron can bind to many things. For example, phytates, which are just molecules, somewhat big molecules that are found in legumes, rice, whole grains. Polyphenols also bind to iron and they impair its absorption. You have vegetable proteins, which follow the same kind of thinking as these, and then fibers. Okay, so all these here are just complex molecules that interact with the iron and prevent it from being absorbed properly. You also have calcium. Calcium is important for iron absorption, but not necessarily through direct binding to iron, more in the sense that calcium is important for the storage and release of the replenishment and uh, emptying of the storage units in the cell of iron. And we'll talk about this in a second. So, as I mentioned, this is just for your own information. I'm not expecting you to learn this by heart, but the RDA for iron is quite dependent on age and on the sex of the person, because for adult men you need about 8 milligram per day to function properly. For women it's a little bit more because of their menstrual cycle, because of well, this is the main thing actually. And so their body requires a lot more. And if you are a pregnant woman, obviously now you are not one person, but you are two people. And because you are two people, then you need to account for the fetus also. Okay. As I mentioned, the best iron comes from the heme iron, and you probably know about hemoglobin. Hemoglobin is a protein found in animals, in the blood, and so you would expect that meat, poultry, fish, clams, oysters would have the highest amounts of iron. Okay, there's also enriched foods, because as I told you, Canada likes to enrich foods by adding iron to it, but it's only a small amount compared to what these contain. Okay, so there's two types of iron available, like in terms of biologically relevant iron. So you have, for oxygen transport, I mean, you have iron found in the form of hemoglobin, and this is basically 60% of the iron in your body. And then you have iron in the form of myoglobin, which is kind of similar to hemoglobin, and this is basically 8% of the total iron reserve, let's say, of your uncirculating iron. Hemoglobin is pretty much the same as myoglobin. The only difference is that its quaternary structure is 4 units of this. Okay, and so this is a tetramer, this is a monomer, and this one is more efficient at binding and carrying oxygen than the hemoglobin itself. But hemoglobin carries, oxygen. But hemoglobin carries 4 molecules of oxygen compared to myoglobin, which has only one oxygen carrying center, let's say. Okay. Myoglobin is found in the muscles, while hemoglobin is found in the blood, because these are the two major components of the body that require oxygen in huge amounts, let's say. So that's 68% of the total iron. The remaining iron is found in different places of the body, including the storage units, which we'll talk about in a second. Some of it is bound to transferrin, which will be carrying it in the blood to other places. So transferrin is a molecule that binds iron to bring it somewhere else. While hemoglobin contains iron and it's also in the blood, but this goal is to carry oxygen. Okay. So transferrin is a glycoprotein, meaning that it's a sugar bound to a protein, and other cells that are receiving this iron contain receptors that will bind to transferrin and allow for the uptake of the iron. Okay. Cytochromes, you have so many of these. These are important for redox reactions for metabolism. They turn one molecule into the other and keep passing the electron or proton one way or the other. And so these cytochromes contain iron at their center, and this is important because iron is very good at oxidizing, and so this allows for the transfer of electrons. Obviously, if it's important for redox reactions, then you would expect it to be in the electron transport chain, which is just basically a chain of transport of electrons. And actually 5% of the total iron of the body is found in the ETC. Okay, catalase also uses iron, and there are many other molecules. Okay, so let's say you eat an iron-rich diet, and then your body has enough for all the processes. Where does the rest go? Well, part of it is going to be stored as ferritin and the other as hemosiderin, and these are just storage units of iron. Okay, and they store it in the cells, and when it's needed, it will be released. Okay, the storage of iron is primarily in the liver. This is probably why you well, I don't think in the Western world you don't eat that much liver, but if you are from other different places in the world, you do eat liver. And so sometimes we would hear, like, for example, in my culture, that the liver is rich in iron and it's good for you and whatnot. It's because the major storage units are the liver, not units, but organs are the liver, bone marrow, and the spleen. Okay. Women have lower iron stores than men, and this is due to their menstrual blood. So every month they lose quite a huge amount of iron, and so this is why they don't have time. They don't replenish them completely because they're just using the iron that they're taking, and then whatever is saved gets lost again. And also because of lower dietary intake. In general, obviously this is not a fact, but in general, men tend to eat a lot more meat, and a lot more amount of meat, and so they have kind of a higher intake of iron. Okay, so very quickly, iron, if it can come from two places, as I told you, if it comes from the vegetables, the non-heme iron will be broken down by stomach acid, and that will release the ferric iron. This ferric iron will be either bound to something that is undigestible because it will interact with it in your digestive system and then just be released, or it can be also absorbed and transported in the intestine through the transport protein, which will bring it inside the enterocyte, and then the enterocyte kind of determines, do we store it or do we send it somewhere else? So if we decide to store it, right? If we decide to, let's start with the simpler one. If we decide to send it somewhere else, what's going to happen to that iron, that ferric iron, is that it will be reduced to ferrous iron and then be bound, be basically excreted from the enterocyte through the ferroportin, and that will lead to it binding to copper containing enzyme and then go in the blood. Okay, I don't expect you to know each of the steps. Just understand that when the iron goes inside the enterocyte, it gets reduced, and then it will bind to transferrin in the blood. It gets reduced, then oxidized, and then bound to transferrin, and then transferrin will allow it to go through the body and go wherever it has to go. Okay. If you eat heme iron comes inside a heme, and it's already in the form of this ferrous iron, and so it can directly go to the blood, get oxidized, and then transferred. So this is in part why it's more absorbable. It's because it does not require additional steps of reduction, for example. Okay. On top of that, there are enzymes that break down the heme that release this form here. Okay, this form is found in the heme. Additionally, if you want to store it, now you need to oxidize it, and to oxidize it, you turn it into the ferric iron, which is then stored either in ferritin or homosiderin state. And that's all you need to know for this process. So just two examples of hemoglobin and myoglobin, and then the electron transport chain to show a bit the role of iron. So you have iron here that binds, that is at the center of this heme group. And this conformation here allows it to bind oxygen and transport it, and makes it quite efficient at doing so. This is quite an interesting shape for a molecule, let's say. Myoglobin is only one. Hemoglobin, there's four copies like this. Okay, obviously they're a bit different, but in general, it's four copies of this unit. The electron transport chain, all the cytochromes contain iron, and they get oxidized or reduced. And then at the end, that leads to producing water from oxygen. So this is why you need oxygen and to produce energy. Okay. Here it's just a question of the potential of a electron. So it starts with a high potential, and every transfer decreases its potential, and that releases energy. Okay, and that's all you need to know about this. If you take too much iron, a few things happen, but usually whenever you take anything in extra, your body will try to kick it out, and to kick it out, it will, you'll be nauseated, let's say, vomit, have diarrhea. That's just your body trying to get rid of it. Iron overdose is common in children because parents tend to not have the ability to assess the amount of iron that the kid is taking. And so they just make this kind of mistakes. There is also a disease, kind of a disorder, that leads to excessive absorption of iron. And this is called hemochromatosis. We talked about this in the past. Obviously, to decrease this, you can just reduce dietary iron intake, avoid high vitamin C intake. So we talked about vitamin C being one of the necessary vitamins for iron uptake. Obviously, if you are intoxicated with iron, then you'll probably have the doctor take up blood from you, and blood removal will decrease the amount of iron in your body. And this is usually done for hemochromatosis, but if you have an overdose, also this can be used. So iron deficiency can happen in different stages. The first stage is that you basically are not taking up enough iron. And when you don't take up enough iron, what happens to your body is that you will start using up your stores, which will lead to reduced ferritin levels, which is your storage unit of iron. But you don't necessarily have physical symptoms because you're still replenishing your pool of iron, let's say. Second stage is where you now used up your stores, and so now you don't have that much iron left in your body, and so you will decrease its transport because you don't have any of it anymore. You will reduce the production of heme, you will reduce the production of transferrin, and as you can imagine, if you're reducing the amount of heme you're making, that's going to affect your oxygen transport, right? And so you will start having physical symptoms, including reduced work capacity and others. The third stage, which is the most dangerous stage that actually a lot of people undergo, especially women, is iron deficiency anemia. And this leads to your body not producing even the red blood cells, starting to produce less of them, right? Because you don't have the iron for it. So what's the purpose of making the blood cells? Right? You have inadequate transport of oxygen in the body, and this can lead to fatigue, pale skin, reduced performance, and a lot more. And obviously, you can imagine that the next stage is pretty much death. Okay, energy balance and body weight. So, when we're thinking about body weight and energy balance, we have to think about two main concepts, which basically determine the your body weight, obviously, and the amount of energy that you have available for yourself. Okay. And so, if you remember from lecture 2, if I'm not wrong, we were talking about the amount of energy that you take and the amount of energy that is spent. And that if you spend more than you take, then you will lose weight and whatnot, right? So the energy intake, there's only one source, and it's the consumed food. And so when it gets broken down, it releases energy. And then for energy expenditure, the energy that you use up during the day, well, this is divided into different categories, but basically the foundations of it are the amount of calories that you need to when you are sitting, right? Or resting, more like it. The amount of calories that are needed for your daily activities, exercise, and whatnot. And then there's another one called the related to breaking down the food. Okay, and so if you do a balance between these two, this minus this, it will tell you if you are in a calorie deficit, and so you are going to lose weight, or if you are over, if you still have too much calories because you didn't burn enough, where you will be gaining weight. Okay, so before we get into all that, let's just talk about a healthy body weight, what it is. And so the healthy body weight, obviously, as you know, depends on your age and the state or where you are in your developmental state physically. And so it's usually, obviously, if you are um, obviously if you are at a stage where you are growing, then a healthy body weight, for example, will be totally different from a child or whatnot, right? um, Usually it's a weight that is maintained without doing anything to it. And so this, but again, these are just like guidelines. They're not fully 100% true if you take them apart. Let's say, for example, if you use this here alone, it's not really true. So maintained without constant dieting, yeah, you could be 300 pounds and maintain that weight, right? Actually, you will be probably maintaining it because you won't be able to lose it. So it's not only this by itself, but all together makes it a healthy body weight. Okay. It's based on genetic background and family history of body shape. So some people have genetic predispositions to getting, let's say, or losing weight faster because they have a faster metabolism, or the opposite, right? So depending on the state, that will determine what's your healthy body weight for you. Body shape obviously also plays a role in determining what's a healthy body weight. We are not all in the same shape and form, and so that means we are not going to have the same body weight that is considered healthy. For example, if you have bigger bones, well, you'll probably weigh more if you are the same height than someone else that has smaller bones. And so that's your healthy weight for you, but for them it would be probably a bit overweight. Okay, so obviously, to more scientifically speaking, a healthy body weight is dependent on your ability to keep a healthy amount of blood pressure, lipid levels, and your glucose tolerance. These are actual indicators of a healthy body weight, more scientifically, let's say. A healthy body weight obviously will come from good eating habits, regular physical activity. It's clearly not going to come from poor eating habits and no physical activity, and it's acceptable to you. So this is important because the psychological effect of the body weight is important also. And so sometimes people, even though they do have a healthy body weight in terms of scientific, because body weight is a range. It's not really just one number for each person, it's a range, right? So some people, if they're in the lower end of the healthy body weight, it might not be acceptable to them, and so they'll try to go a bit higher, and so that can play a role on your psyche, let's say. Okay, so it needs to be acceptable to you, because if it's not acceptable to you, then although you are healthy in terms of scientific medical, let's say, tests and levels of lipids in your blood and blood pressure and whatnot, it might have the opposite effect on your psyche and make you do things that are not healthy. Okay. An unhealthy body weight, well, quite simple. You can either be underweight or overweight. Underweight is having too little body fat to maintain health, because body fat is quite important for health. Overweight, then that means you have a little bit more like an excess body fat, and that's starting to increase your risk of health problems. Obesity is when you have too much fat and it's starting to basically affect increased morbidity. And then you have morbid obesity. This is when you have double your weight, your healthy body weight or more. So let's say, for example, if your healthy weight is 60 kilos, well, you're 120, right? So this is morbid obesity, and this is guaranteed serious health consequences within a span of 5 years. Okay. So to determine the body weight, in the past, we used to do it just by body mass index, the BMI. You've probably calculated your own in the past, but actually, this is not sufficient because the percentage of different of the fat in your body can affect this. So you can still be healthy in terms of BMI calculated, but then your fat percentage in your body is like something like 30%, and you don't have enough lean mass, so that's unhealthy. Okay, so the body mass index is the first number that we think about when we talk about body weight, and the state of the body weight, if it's healthy or not. But that's not sufficient. We usually add to it a measure of body composition, and this is basically how much fat you have in your body. And then we assess the pattern of the fat distribution, if it's on the organs or if it's abdominal. It's a different story. For example, if you have a lot of fat but you look slim but your organs have a lot of fat on them, then that's not healthy, even though you might fit in the body mass index, the healthy body mass index range. So let's start with the first one. The body mass index is very easy to calculate. It's the ratio of weight to square root of your height. This is when we're talking about the international system of units. And so if you're thinking in kilos and meters, then your BMI would be your weight in kilos divided by the height squared. If we're talking in terms of pounds and inches, then the formula changes a little bit like this. And so your weight will be in pounds divided by your height in inches squared times 703. And this is just a factor that was found to convert, right? Now, if you remember from the quiz, many of you asked me what I find kind of a unfortunate question. Some people were not even happy that they were asked this question, where I was asking about lbs and inches. So my first statement for that is, you're at university to learn, okay? And this is you're not there to determine what type of question is being asked. You're there to learn the material for your own benefit. Obviously, society has made it so that grades are important, and people start doing weird things about grades to get better grades. And so they start choosing the questions of their exams and quizzes and complain about these and think that the professor is tricking them by doing this thing. But here in Canada, we use two systems, okay? And in the US, we use one system most of the time, okay? And so obviously, I expect you to learn what a kilogram is in lbs, what a meter is in lbs, what an inch, what a foot is in inches. This is basic knowledge that you should have acquired a long, long, long time ago. If you don't have this, this is not normal, okay? So you need to understand this differentiation here. And you will be tested on it, just like you were tested on the quiz. Now, on the quiz, I was nice with you guys. I just gave you the numbers myself because I did not expect you to not know stuff like this. Okay, this is not part of nutrition. This is basic math, basics. Okay, so I don't want to hear any about this anymore. I hope in the exam you'll be able to think about this. Let me just try to get the pen there. Well, I don't know where the pen is. I guess there's no pen. It's here. Camera, arrow, option, screen. It's this. No. Okay, anyways, doesn't matter. 1 foot is 12 inches. Okay. 1 inch, if you want to convert it into centimeters, is 2.5 2.4 centimeters. So if I give you 5 foot 9 inches, you have to convert the foot number into inches, add it to the inches that are there. So 5 foot times 12, that's 60, plus the 9 inches that was there, that's 69. And then you want to convert this to centimeters, you'll do times 2.54, and that should give you 175 centimeters. And hopefully you know how to convert centimeters in meters at this level. I mean, this is crazy. And in terms of pounds, 1 kilogram is equal to 2.2 pounds. Okay? So learn this, because in the exam, I'm going to mix it up. Pounds, meters, whatever you want. Okay? I expect you to know this stuff here. The BMI values that are healthy are usually between the range of 18.5 and 24.9. Above or below that, below this you're underweight, above this you're overweight, and then you can be obese and morbidly obese, and that has increased health risks. Okay, this you can do it, just divide this by 1.76 squared. It should give you one of these values. Okay. Now, the limitation of the body mass index, obviously, it's not an indication of body composition, because you can have more percentage of body fat with the same BMI ratio. Does not give you a fair indication of overweight or obesity in people older than 65, because as you grow older, you will start to have osteoporosis, or you will start losing muscle, and that will make you smaller in height. So this is not a good indicator. Does not accurately reflect muscle and bone growth in children and older people, because we have different rates of losing muscle and bone as we age, and we have a different rate of bone growth and muscle growth when we are young, and so it's not a good indicator. It does not take into account your physical and metabolic differences, especially between different ethnic backgrounds. And yes, the ethnicity or the region from where you come in the world in general is has kind of a different effect on the BMI. Okay, there are regions in the world that on average, epidemiologically, they are taller than other regions in the world, and so that right there is a problem for measuring the body mass index. Okay, and obviously if you're an athlete or you're a bigger person, you might have a lot more muscles for a given height. That does not mean that you are overweight. So again, body composition plays a role in here. So this is the graph that is used to determine where you fit in the body mass index. If you're measuring in weight in pounds, so let's say, for example, for me, I would be about here, and then you go up with your height, and you'll find if you are in the healthy zone or not. Okay, so me, I'm in the healthy zone, getting towards the overweight, but obviously, let's see. Yeah, if I gain, let's say, 10 more pounds, I think I will start being in the overweight region. Okay, this is just how risky it is for you to get health problems. Obesity starts at 30. Okay, overweight above 24, and it goes in increments of 5. Okay, and so the least risk of health problems is obviously between that range. If you're below, that's an increased risk, and if you're morbidly obese, then you'll have very high and high, extremely high range of potential for developing health problems. Body composition, there are 3 ways to measure this. You can use the skin fold method, which is just folding the skin right here on your rib cage and then measuring the size of that, and that has a kind of gives you an idea of the body percentage, because obviously if you have more body fat, then you'll have more skin fold, let's say. You can also do underwater weighing, and this is usually done for competitions or for training for athletes. You weight yourself on land, you go in the water, you sit on a chair that is on top of a big balance in the water, you weigh yourself again, and that gives you a difference for the 2 weights, and the difference is linked to the buoyancy of your fat. So it floats in the water, and so it decreases the weight, right? And then it tells you the body fat, basically. Okay, And then you have your bioelectrical impedance analysis. So you're just giving a shock to your body, and whatever resistance happens is returned to the machine that's calculating this, and will tell you how much fat you have. Okay. The third concept, or the third important thing to do when you're talking about healthy and unhealthy body weight, is looking at the fat distribution pattern. Men tend to have an apple-shaped fat patterning. So that means the upper body has more fat, and this has an increased risk for chronic disease because it's around the abdominal region where you have your visceral, where you have many of the important organs, and so the accumulation of fat happens here. Women tend to have a pear-shaped fat pattern, and this is usually fat increasing up in the waist. Um, I mean the hips, sorry, and it has lower amount or lower risk for chronic disease because there are um, no, let's say, important organs in this region. Okay, there are numbers, general numbers that are used to determine if a fat distribution pattern is healthy or not, but obviously these again are not sufficient by themselves to determine if a person has healthy body weight or not, because the ratio of protein to fat is also another important factor, right? But in general, there are two measures that we do: the waist to hip ratio. And so you will take the part here of the body, you'll measure it, and then you'll measure the other part, which is the hip. So you take the widest part of the hip, okay, which is not here, but a little bit lower, and then you make a ratio of that. And if the ratio for men is higher than 0.9, that means that you have an increased risk for chronic disease. Um, and so if for women it's above 0.85. Okay, these are general. In reality, there is specific ranges for different ages, but in general, it's this. For the waist circumference, for men, if you're above 40 inches, that's an increased risk of chronic disease. In centimeter, 102. And then for women, it's above 35 inches or 88 centimeters. Okay. This difference here, it's because of the pear-shaped and apple-shaped. And so when you reach this point above 40 inches, you're starting to accumulate fat on your organs, and that's not good. So losing weight and gaining weight, this is basically dependent on your ability to take in energy and the amount that you spend during the day. There's also a factor that plays in it, which is the genetic factors or predispositions of different people, and I'll talk about that in a second. Behavioral factors, well, if you don't eat lunch because you're at university studying hard and you don't want to fall asleep in the afternoon, that's a behavioral factor that plays on this. Childhood weight, obviously, if you grow up and you're young and your parents are just giving you too much food, your body learns that it needs to eat a lot, and so this plays a role later on. The opposite is also true. So your childhood weight plays a big role in the amount, in your ability to gain or lose weight. And there are social factors also. If you're always, you know, if every time you pass by, I don't know, Starbucks, you take also, well, that's a behavioral. More like if you're always going out to a specific restaurant, you're with your friends, you're always, eating this or not. Or if you're going, for example, to a bar with your friend every Tuesday when you're drinking 8 different drinks, well, that's going to play on your weight gain. So these are social factors. If there's peer pressure for you to eat a specific thing, and yes, it does happen. Sometimes you go with people to places, but you don't necessarily want to be there or eat whatever they're eating, but you're just going there for the social effect, so you still eat what the hell they're eating. So this plays on it. The movies, although it's not that social, but people see it as a social activity. You're eating popcorn and tacos and whatever the hell you eat there. Okay, so this is a social factor, let's say. So the balance of intake and expenditure will determine which direction you're going in. If you're going and doing a lot of exercise, yeah, you'll be spending a lot of energy, and so that will weigh more than the amount you consume, and that will lead to losing weight. Usually, if you have a healthy weight, you try to keep it here. The opposite is not good is when you're taking too much energy and you're not spending enough, then you will gain a lot of weight. So sedentary lifestyle, eating too much, active lifestyle, eating little, and then keeping it right here. Okay. So how do you calculate each of these? Well, let's start by the energy intake. This one you already know. You add up the amount of grams of protein and carbohydrates, you multiply that by 4, and then the grams of fat in your food and multiply that by 9, and that will give you the total energy that you took during the day. And you've been doing this the whole semester. You've been logging the food that you were taking in. Well, that's your energy intake, and you can use those numbers to calculate this. Energy expenditure is a little bit more complex. It's divided into 3 categories. You have the BMR, which is the basal metabolic rate. The basal metabolic rate is the amount of energy needed to maintain a basal or resting function of the body, like breathing, blood circulation, producing cells, and whatnot. And this accounts for 60 to 75% of the total energy that is spent during the day. The thermic effect of food is the energy required to break down food. So breaking down food requires energy because you need to basically digestion, absorption, and transport require energy to happen. They don't just happen like that. Metabolism, additionally, and storage of the nutrients. So this is called the thermic effect of food, which is 5 to 10%. And then you have also the physical activity energy cost. So this is the amount of energy that you need during the day to do physical activity. For example, if you're sleeping all day long, well, this will be close to 0. Okay. And if you're like me, walking all day long or thinking all day long, because also cognitive function spends energy, and it's not a basal metabolic rate, it's not a thermic effect of food, it's part of the physical activity. Okay. So the energy spent in this category. As university students, you're probably spending the whole day thinking about complex concepts. So this is part of this here. Okay. This is the one that's most variable between people. Some people spend too much time watching Netflix and they're not really doing anything. Others are working out in the gym like 3 4 times a week. Others have like for me, for example, I move a lot. I'm moving nonstop. I usually tend to switch between tasks, similar to a bit to ADHD. And so my energy cost for energy expenditure is quite high. As a matter of fact, even the thinking or the research that I do requires a lot of energy. So I spend quite a lot of energy, and this is why I barely gain weight no matter what the hell I eat. That's because I'm spending a lot during the day. Okay. There are 2 ways to measure energy expenditure. You can do it through direct calorimetry, and this is just a way to measure how much energy you're spending, because energy expenditure produces heat. If you've ever taken thermodynamics or learned about the thermodynamic laws, you know that when energy is transferred or converted, it releases a little bit of, it's not a perfect process, and it releases a bit of energy as heat. So this is the direct way to measure energy expenditure, because if you know how much heat was released, you can convert back to how much was used or spent. And direct calorimetry usually will use oxygen consumption as and carbon dioxide production as a way to measure energy expenditure, because if you remember, your mitochondria are going to be making energy, okay, and they require oxygen, but then they will require oxygen to produce water, right? So the amount of oxygen that you are taking in to produce energy will determine actually let me rephrase that, because I was talking about the opposite process. Okay, but oxygen and carbon dioxide are processes that are important for the amount of energy that you are producing and spending during the day. Okay, and so when you are doing exercise or moving, you will increase your uptake of oxygen and your production of carbon dioxide, and these can be used to measure how much energy you are spending. right? A sprint requires, well, let's not use the example of sprint because it's anaerobic activity, but let's talk about, for example, running compared to sitting. Obviously, you're running, you require more oxygen, probably you're breathing faster, so you'll produce more carbon dioxide. Okay, these are the factors that affect basal metabolic rate. You can learn these. I talked about these in the lecture. I'm not going to go over them again. Just read them and learn them. They're important for you, okay? This question I asked in class, who has the lowest BMR? It's the female couch potato that is not doing anything, just laying down. And so this here requires less energy to keep that state. But if I ask the opposite question, then we have to think about this table here and how many of these do we fit in the answer. So for example, in nursing mother, well, nursing mother is basically has a child that she's giving milk to, and so that's additional energy requirements. She's also a yoga teacher, so she does physical activity probably on a regular basis, and so she probably has a higher BMR. Okay. Body fat, all I want you to know here is that it's not that two people weigh the same thing. On the balance, that they have the same amount of muscle and fat. For example, here these two have 150 pounds each, but this person here has only 120 lbs of lean body mass, and the rest is body fat, so 20% body fat. This one here is probably healthier because of the lower body fat. Obviously, 0% body fat is not good. Usually try to stay within a bit more than 10% of body fat, okay? If you've seen bodybuilders, you can kind of see their veins. That's because they have a low body fat, and so the skin is directly on top of the muscles and of the veins, and that gives that effect of the veins coming out from the body, okay? This is pretty much the same thing, just another example. Okay, so let's determine the BMR, because we talked about energy intake, and that's just calculating the number of calories that you are taking in and multiplying like proteins by 4, kilocalories per gram, carbohydrates by 4 also, and then fat by 9. But the BMR, the way to calculate it is like this, okay? You will take the weight of the person in kilograms, multiply it by this constant here, 1, times 24 for 24 hours a day. In general, men tend to spend for their BMR 1 kilocalorie per kilogram per hour of a day. Women is 0.9 kilocal per kilogram per hour in a day. Okay, and this will give you your basal metabolic rate. If I give you the weight in pounds, you need to know how to do this. Okay, then after you calculate your BMR, you will also include the activity level that you have. And so the energy expenditure is BMR plus activity level energy. Okay. If you want to be very specific, you can find the energy cost of each activity that you do during the day. So for example, sitting will cost you 0.026 kilocal per kilogram of body weight per minute, and then you add all of them up, and that will lead to the amount of energy that you have spent in a day. Obviously, this is tedious. You can just follow kind of a range, and you can also measure it as a percentage of the BMR. So a sedentary lifestyle where you're mainly sitting all day long, like for example, when you're working in front of a computer, for men, you'll usually spend between 25 to 40% of the BMR. So you calculate the BMR. Now you need to calculate the physical activity level, and you can do that as a fraction of the BMR. And these are the proportions. Okay. So if you're a man mainly sitting, you'll probably be spending for mainly sitting 25 to 40% of your BMR. Okay. Let's take a look at this question here where I'm talking about Henry, which is a 70 kilogram male, moderately active. Um, and the question is asking how much calorie he should take to maintain his weight. Okay. First, you need to calculate how much he spends. So you start by the BMR, right? Which I've shown you right here. So the weight in kilograms times that constant that I told you about, which is 1 kilocalories per kilogram of body weight per hour, times 24 hours, and that gives you 1,680 calories. That is the BMR of Henry. Then you need to calculate the percentage of the BMR, which is basically the activity level. And since he's moderately active, it's between 65 to 80%. You can take the middle of that, which is 72.5, for example, as an average, multiply it by the BMR, and you'll get 1,218 calories. You add these two, that gives you the amount of energy spent during the day. And so if you're trying to maintain that same weight, then you will probably be eating this amount of calories. Okay. Your roommate decides to lose weight for her high school reunion by eating a 700 kilocal diet. So that's basically decreasing the diet by a lot. Usually you need around 2,000. Initially, she loses weight rapidly, but the weight loss slows after about a week. What might explain this change in the rate of weight loss? Well, if you're decreasing this to this amount here, um, you're going to start losing weight quickly because you're in a calorie deficit, but your intake of food will also decrease, right? And so after a certain time, this amount of food here requires less energy to break down, right? And so your weight loss will not be as efficient because you need less energy to break down the food because you're eating less food. And so you're spending less food, you're spending less energy because your intake of food is smaller. Okay. So a person with 2,000 kilocal diet will have a higher TEF than a person that has a 700 kilocal diet because they both, and so the expenditure for this person is to break down this food is lower than a person that eats 2,000 calories. Okay. Genetic factors. If you were ever curious about what's the percentage uh, of body fat that is accounted by genetic influences, it's about 25%. Your height determines how much fat you have, your body shape, your metabolic rate. For example, me, I have a very fast metabolic rate, and so my genetic heritage, let's say, makes me have less fat in the body. Okay, the rest is non-genetic, so it's still 3 to 1, and so the other factors are environmental, societal, behavioral, and whatnot. This year I talked about it in the classes just to show that the book is kind of taking the wrong approach to teach people how to lose weight, and it calls it a sound weight loss plan. But in reality, there's no person that can handle this, and because body weight loss of weight is more something that you that plays on your psyche than actually measuring 1,000 different things and making sure you are within ranges. As a matter of fact, one habit is hard to keep, and so trying to keep all these habits at the same time is almost impossible for a person that usually got to the overweight stage because they are not disciplined. Okay, but in general, there are a few things that are important. Like, obviously, I talked about this um, in the lipids lecture, but you need to decrease the amount of saturated fat, of cholesterol, increase the polyunsaturated fats to a certain point. Carbohydrates should stay within the MDR and whatnot. Okay. So this is what we learned. And obviously, you need to decrease the amount of kilocalories that you take during a day, for instance, but never go below 1,200 kilocalories a day because this will become kind of dangerous. Okay. How to achieve this? The reality is requires not all these constraints, but something different, and is actually more or simpler than that. You need to be able to decrease your energy intake because this is the most important. Okay, A burger, it probably takes you like 5 minutes to finish, but to burn the fat, burn the energy that came from that burger will require about 2 hours of running, if not 3 hours of somewhat moderate intensity running. Okay, and so the energy intake plays a very important role on losing weight, and you need to gradually change this. Some people wake up the next day and it's January 1st and they think they're gonna lose weight. They will stop eating many things. They will last 2 weeks and then go back to how they were before, and that's just because the discipline has not been put in place. What's important is to gradually change your energy intake. Physical activity is important also. It helps burn the excess fat in your body, and so you need to choose the appropriate physical activity. For example, sprinting will not make you lose weight, but running at a moderate intensity or biking will start using up your fat stores, right? And obviously, behavior is the major component in here, because if you don't have proper behavior, then you will not decrease your energy intake and not start going to the gym or whatnot. Okay. Um, Again, you could still lose weight without going to the gym. Why? All you have to do is decrease your energy intake, and through time, your body, your physical activity, like your even sitting, will use up energy, about 25 to 40% of your BMR for men. And so, if you change your energy intake to the point where you are in a deficit, then you don't even need this physical activity. But obviously, physical activity has other benefits. It's not just to lose weight. So that should be taken into consideration. People who tend to fail because they try to implement 2,000 different things to do and then they are not disciplined to even just do one of them, they will usually resort to weight loss diets. If that doesn't work, they'll start using medication, and if that doesn't work, they'll start doing supplementation and go into even doing a bariatric surgery. Okay, so weight loss diets, I'll just give you a few characteristics of what usually they have. So usually a weight loss diet will contain about 11 to 19% of fat. Well, I mean, the total energy that comes from the diet that is from fat is usually 11 to 19%. So the AMDR is what I'm talking about. While very low fat diets contain less than 10% of fat. Again, this is healthy and unhealthy, depending on if you have too much fat and you have stored too much fat. If you're having your essential fatty acids, then you can go below the AMDR for fat. You just have to be, because your body will use its own storage of fat to replace for that. Okay, but usually this is a dangerous range to play in. You try to have complex carbohydrates and fibers, because simple sugars will be converted into fat. Fiber is, some of it is non-metabolized, but it will help for the elimination of whatever excess food you have. Regular physical activity is important for maintaining a healthy body, including building muscle, burning fat, having just better structure, better posture, and many other things. Obviously, these weight loss diets require lower LDLs because cholesterol is not good for you, triglycerides, glucose, and insulin levels, and will lead to lower blood pressure. Okay, blood pressure is due to insulin, glucose, LDL. This, I just showed it here as an example to make fun of this part here. Like, the way the book talks about this shows clearly that the person has no experience in terms of actual losing or gaining weight, basically the idea here is that you can eat up about the same amount of food and still have less kilocalories. And so if you just make sure that you switch the things that you are eating, you can actually lower the amount of calories you are taking. One thing that is funny here is that, and actually, I'm not even sure how they did not get sued about this, but here they're talking about as if McDonald's is unhealthy, and then Subway uh, is something that is healthy. Yes, it is a bit more healthy, but I can argue the opposite. Okay. The other weird thing here is like, who the hell eats Oreos at night? At night, right? Maybe people. Actually, I'm not sure. Maybe people eat Oreos at night. The way I know Oreos is the morning with milk, but and then the book is funny because it's telling you, well, if you have a problem with eating Oreos, instead of eating six, you can still keep the Oreos and eat three Oreos, right? This is obviously just scientists trying to write books, let's say. Okay. In general, just decrease your intake. Doesn't matter which one you're having. Try to decrease your intake. Obviously, this is not as healthy. Try to avoid this because of the trans fats and whatnot. But in general, just decrease the amount of calorie, and that's sufficient to put you in a healthy state. Okay. Medication. I have a friend that was trying to take this medication that he bought from eBay. Obviously, you can buy illegal medication in Canada through eBay, and people will ship it in an envelope, because in other countries it's probably legal. And usually, weight loss medication should be used only under the physician's supervision, because they play a role on a lot of your metabolism. For example, uh, sibutramine reduces appetite. And so, if you don't have an appetite, you will not be eating. Uh, or Orlistat inhibits fat absorption, and you can see how this is going to make you lose weight. If you don't absorb fat, it will be eliminated with whatever waste you have in your body, and that will lead to weight loss, let's say. There are others that are more dangerous, that increase the rate of uh, energy production, and so burning down the fat to make energy in your mitochondria, but that leads to increased body heat and can lead to heat strokes and whatnot. And that's quite dangerous, okay? Dietary supplements, as I told the class, there are these teas that claim to be able to make you lose weight. There are these supplements that claim to help you lose weight. These supplements can be sold by anyone, and they require usually just a simple process to be approved for the government. So all those supplements that you see in the store, in the pharmacy, ginseng and whatnot, ashwagandha, if people have thought about anxiety and they were looking for something to help with the anxiety, they probably found ashwagandha. So these are dangerous, okay? Because first of all, they were not studied clinically, most of them, and so you will take them not knowing if they are good for you or not. Second, if you are taking medication and then you take it along with these supplements at the same time, and your doctor is not aware of it or does not know the effect or the interaction between the molecules found in the supplement and the medication you're taking, that can lead to a bigger problem. For example, people that have anxiety, they usually will be prescribed Ativan or lorazepam, which helps with the anxiety. But then if you, on top of that, they take ashwagandha because they think that there's no issue with it, and this is a supplement sold without prescription, then it must be okay to follow just what's written on the bottle. Then that can lead to lower heart rates and even a cardiac arrest. Okay, so these dietary supplements do not undergo clinical trials in depth, just like molecules or drugs. Okay. Sometimes people will add to these dietary supplements caffeine, which they say will stimulate your metabolism and speed it up, but this is kind of controversial and dangerous. Ephedrine is now illegal in Canada, but it used to be illegal, and PPA. Okay, so I have to be careful with this stuff here. So if you're trying to gain weight, the opposite of losing weight, then you are probably in the underweight category. And so you need to gain weight, but you have to be careful because you don't want to take up too much fat and just eat whatever is coming in, because that can lead to other problems. And so your fat intake should be less than 30% of the total energy intake. You try to add an additional 500 to 1,000 kilocal a day, and you'll see that this is quite hard to do because you don't have the appetite and the hunger for it. And so you need to eat frequently throughout the day instead of just trying to get 1,000 kilocalories in one go. There are these weight gainers or mass gainers that you can buy, which is basically a powder that you add to milk and you drink, and you can carry this around with you throughout the day. But this is not something that is consistent. You need to increase your diet a little bit and do it gradually so that your body gets used to it. And obviously, you can exercise regularly to help gain muscle mass. Now let's talk about morbid obesity and obesity. So when your BMI is above 30 to 39.9, this is basically when you reach the morbid obesity rank. No, obesity is 30. Morbid obesity is 35, if I'm not wrong. Just verify this information. I don't remember them by heart, but morbid obesity is when you have 100%, basically the double of the normal weight. So if you're supposed to be weighing 60 kilos and you weigh 120, you're probably morbidly obese. This epidemic in the United States, they have a lot of morbidly obese people, and it's linked to many diseases. Hypertension, obviously, too much fat leads to blood pressure increasing, dyslipidemia, so dysregulated lipid quantities and composition of the blood. Diabetes is linked to insulin and linked to obesity as well. And so if you're taking up too much glucose, then you'll become insensitive to it, to the insulin. And if you become insensitive to the insulin, that can lead to diabetes because you'll be producing more insulin. And so smaller amounts of insulin will not be doing anything good to you. Heart disease, obviously, it's linked to the hypertension, and then stroke. Well, if your heart is working too hard, it will lead to a heart attack or a stroke. You can also reach a point where you have something called the metabolic syndrome, and metabolic syndrome is many things disrupted at the same time, and that leads to increased heart disease rate, type 2 diabetes, and stroke. Usually, the way to determine if you have metabolic syndrome is to measure a few things. First, your abdominal obesity. You need a waist circumference of above 40 inches for men and 35 for women. The TGL levels in your blood should be about 150 milligrams per deciliter of blood. HDL levels should be low, so this is the healthy cholesterol. It should be below 40 milligrams per deciliter in men and 50 milligram per deciliter in women. Blood pressure should be above 130 to 85, so your systolic and diastolic blood pressure. And the fasting blood glucose should be above 100 milligrams per deciliter. Okay. The treatment for obesity, you can start with a low-calorie diet and regular exercise. You can have prescription medication, as we talked about, but then some people undergo surgery, and these are just variations of surgeries that happen on the stomach. A normal stomach looks like this. If you're undergoing a vertical banded gastroplasty, then you'll add kind of a band. You make a hole in the stomach, and then you add a band here, and this decreases the amount of food that goes into the stomach. And so your stomach will take more time to take in the food, and that will prevent you from eating more. Otherwise, you can also bypass the stomach and just remove it completely and come and leave just a small portion of the stomach. Now, this is not the best, the gastric bypass, because obviously this decreases the digestion, the initial digestion of proteins and whatnot. Or you can just add a band, the gastric banding, which is adding a band to the whole stomach, and this will decrease the speed at which food goes in the stomach, and this is similar to this one here.